Morning, everyone. I'm really excited to share our monitoring story with Grafana with you all today. Before I get started, I would like to give you a brief introduction by myself and my company. So my name is Gong. I'm a software engineer working in Tinder's observability team, which majorly focus on the monitoring, alerting, and logging. And for the people who not aware what Tinder is, we are the world's most popular dating site for people to meet new people. With more than 26 million matches per day, we use Grafana as our central monitoring platform for our online and offline workflows. So in today's talk, we are gonna talk about our monitoring journey with Grafana to monitor our hundreds of microservices running inside the virtual machines as well as the containers running inside the Kubernetes environment. I'll also share our way to do the infrastructure components monitoring like the Kafka, Elasticsearch, and Redis. In the last, I will share our way to do the data source auto-discovery and the dashboard auto-creation. In the end, if time applies, I will do a quick demo about the dashboard automation part. So let's get started. So there's a saying that Rome was not built in one day, and in Tinder's Grafana monitoring infrastructure is also not built in one day, and our story starts from 2 years ago. First, let's meet some of our Tinder engineering team members, Alice, Bob, and Charlie. Those are really famous characters from our college textbooks, but this time they work for Tinder's engineering team. Alice in observability team, Bob in backend team, and Charlie in cloud infra team. So one day, Charlie came to Alice and asked her to build our own observability infrastructure to monitor all the health of our services. Alice is really excited about this idea, and she also proposed that we need a central place for engineers to check and view those real-time metrics. So let's first review our current scenario. We had about 50 microservices running with AWS EC2 instances behind those ELBs. And because everything is running on the AWS, then AWS CloudWatch could provide those helpful metrics. And Grafana is a very popular open source tool for the data analytic and visualization for the applications and infrastructure. So Alice decided that we can just enable our CloudWatch on those instances on the ELBs as well as ASGs and etc. So from the Grafana side, it will get the metrics from the CloudWatch data source so that engineers could view and check those metrics from Grafana directly. Then Bob and Charlie is quite satisfied with this. But Bob from the backend team saying that the backend engineers also want to know the details about their services, like the P95 latencies, the request status for different roles, and etc. So to resolve this problem, Alice go and did some investigation about some open source monitoring solutions for this. So she checked that there's many time series database options out there, but for the OpenTSDB, it requires the Hadoop, which currently doesn't fit our scenario. And for the Graphite, it's kind of hard to scale for the open source solution. And for the InfluxDB, its clustering feature is a paid version. So, and for the Nagios, it's kind of like 1 generation old. So finally, the Prometheus came to Alice's eye. Now, without those outstanding drawbacks, Prometheus also provides great client libraries so that developers could use this to expose their application metrics from their code directly. So that's it. Prometheus is the best option for us. Alice went ahead and launched the Prometheus server to pulling the metrics from all of our services. Then from the Grafana side, it can have both the service detailed metrics as well as the CloudWatch health metrics. But these happy days do not last long. A few months later, Bob came to Alice and saying our engineers are seeing those metrics lost from time to time because our business grows so fast that one single Prometheus server couldn't handle them all. Then Alice agreed and understood the current situation and thought we should have a better solution to make our monitoring infra more scalable. So the solution she came up with is to get each service and assign the Prometheus server. So which means that each Prometheus server will only script the metrics from its assigned service. Also, we have those recording rules enabled on different Prometheus server so that it will help enhance the querying performance for those frequently used expressions and those computationally expensive expressions. Also, in this way, we can easily scale this individual Prometheus server based on that service load. Then from the Grafana side, we will have the Prometheus data source for each individual service. Then everyone is happy again. And the developers will have those stable metrics every day. But from the backend team, they want to have the metrics for longer time. Because currently, we were only keeping those metrics for several days for each individual service, but they still want to check some historical metrics for some important data. So Alice proposed two options to solve this problem. One is to just increase the retention period for all of our Prometheus servers, which is super easy, but none of the metrics are needed for this long retention. Then money and the resources will be wasted for those unnecessary metrics. The second approach is to have a separate Prometheus archive server for only keeping those key items for longer term, which will help us use the resource and the budget in a more efficient way. Although this way it requires the actual setup and the module owners need to understand and update the existing configuration. After the comparison, the answer is quite clear. We should do and implement the second one. Then Alice went and launched the archive server, which pulls the metrics from all the Prometheus individual service server and exposes itself as a separate data source to Grafana. Also, we have the data source auto-discovery service running inside this archive server so that whenever a new service came up or an old service got removed, the data source and target's endpoint will always get updated from either the archive server side as well as the Grafana side. Then that's it. Everyone are really satisfied with this solution. But there's always one more thing in our real life. But this time, this thing came from Charlie of our cloud infra team. So from cloud infra team side, they think it is time to move all of our services into the Kubernetes environment for better handling, deploying, and managing those applications at scale in the containerized way. In this way, it will help give us our developers more velocity, efficiency, and agility, and it will also help us save some money. So Alice should definitely do and go ahead support the monitoring infra inside the Kubernetes environment. Then before that, let's first check how our Kubernetes environment look like. So we have different services running inside different namespaces for different clusters. Then from Alice's side, our developers already get familiar with the Prometheus and also have the great experience by using Prometheus to expose our application metrics. So we shouldn't let them redo those metrics instruments in a different way. We should stick with Prometheus for the Kubernetes environment as well. So what's the answer for the Prometheus and the Kubernetes? The Prometheus operator. So Alice launched a Prometheus operator inside the monitoring namespace. Then the service monitor will select the targets will try to monitor, and the Prometheus service itself will pull the metrics from those service monitors. And just like the EC2 before, this Prometheus service endpoint are also exposed as a separate Prometheus data sources to Grafana. Let's don't forget those archived metrics for longer retention. We added a separate sidecar service inside the monitoring namespace, which will help collect all the updated Prometheus service and put that into a separate MySQL database. Then archive server, which is in a traditional EC2 instance, will go and check the database result and pull those targets metrics in and expose itself as a separate Prometheus archive data source. Then problem solved. Do you think we'll get more requests from Bob or Charlie? Yes. So speaking of the emergency, sometimes the issue still happens inside the Kubernetes environment. We also need a way to monitor our Kubernetes cluster itself. But Alice is quite confident about this task because according to the Kubernetes official document, Kubernetes has a large, rapidly growing ecosystem. Its services, support, and tools are widely available. So she launched some node exporters, kube state metric exporter, and etc. in that monitoring namespace and used a separate Prometheus KDS to put those kube-related metrics in. Then this kube Prometheus KDS is also a separate data source for the Grafana to plot the graph related to the kube states. Then that's it. And everyone is satisfied with current solution, but Bob reminded Alice that we shouldn't forget about other infrastructure components like Elasticsearch and Kafka. Can we take that care of? So the answer is yes. There's many open source tools out there available for us to do the monitoring with the Prometheus exporters. For example, for the Elasticsearch clusters, we have the Prometheus Elasticsearch exporter. For the Kafka clusters, we have the Prometheus Kafka exporter and Kafka consumer group exporter. And for some AWS-related infrastructure, we just use the Prometheus CloudWatch exporter. Then problem solved. Okay, so now everything gets settled for the Kubernetes environment. And with this ease of use for the Kubernetes, we can easily scale those testing environments with monitoring. But it's kind of a headache for our developers to duplicate those dashboards here and there for different environments for the similar modules. Then we should this our way to reduce those menu creation work. Because Grafana has many useful APIs, we can definitely solve this problem. So Alice went ahead and developed her customized dashboard automation utils with the help of the Grafana lib in Python with a customized HTTP client wrapper, so that it will help a lot when duplicating similar dashboards for different clusters and for different environments. And I will demo this in the last, if time still there. So to sum up, we use Grafana as a central monitoring place for monitor detailed real-time metrics for each service, as well as keeping historical key metrics for longer term. And we also use this to monitor the services running inside the containers as well as VMs. We use it to monitor the health of kube metrics. We use it to monitor the health of our infrastructure resources, and we did our data source auto-discovery and dashboard auto-creation. Okay, do we still have time for demo? Okay. So this is quite a quick demo. For example, we have those 5 panels defined here for the several Prometheus-related queries. And I have a local running Prometheus with 2 jobs. One is simple hash, and one is the Prometheus. Then I just want to give you a quick demo how we create the dashboard based on different jobs. So there are 2 parts of this script. One is to generate the dashboard JSON. The second part is to update the dashboards using the given JSON. So here, if we refresh, then we'll have these 2 dashboards for each individual jobs. This is for the Prometheus house, and this is for the hash brown house. Yeah, that's it. Thank you.
So first question is, so you mentioned that you have data sources per service.
Yeah.
How do you go about automating, adding, or removing those data sources from Grafana?
Yeah, we have that auto data source discovery job running inside. So every time we're just filtering those different tags for those targets, and we will update that using our own cron job to update that. Yeah.
Okay, sounds interesting. And I think we have one other question from the audience. So can you give us an idea of how much you scaled from beginning to now, and what was the time frame for that growth?
From what?
So how quickly you scaled, so how big, how many, the size of microservices, the size of the volume of clusters that you're monitoring, and how quickly you scaled up to that size?
Yeah, so for the Kubernetes environment, Prometheus scaling is still our current issue right now. We haven't recreate the volume every time. Yeah.
Okay.
Yeah.
Okay, so we have a few other questions here. So here we go. So is the Python library that you're using there available as open source on GitHub? So you demoed a
Yeah,
library?
I will put that into my GitHub later today. Yeah.
Okay, there you go. That's the answer. And one on how many total data sources do you have in your Grafana implementation? And is it problematic for users to find the right one? So you mentioned that you're using tags, I guess is one way to help with that.
Yeah, and that each individual data source is naming with that service name, so that if the developers really care about the detailed information about that service, they will use that service. They will use that service data source. But if they only care about those key metrics, they always use the archived ones, so that will have all the data that are available.
Okay, Let me just have a quick look here. So there's a couple of questions around scaling your Prometheus and whether you looked at other open source solutions, so like Cortex or Thanos. Is that something that you've had a look at or explored?
Yeah, we're still evaluating those and trying to try those, yeah.
Okay. And I think the last one, is there a plan to segregate your data source plugins based on team concept? So like assigning data source plugins for different teams with a new, I guess, teams-based access control.
You mean the access control?
Yeah, or just being able to separate, so different teams, only have a view of certain data sources.
For our production one, everyone has the access to that. But for the individual testing environment, each team have their access to different testing environment.
Okay.
Yeah.
All right. Thank you very much.
Thank you.
All right, everyone, big round of applause.